Hi there, I'm just playing around with a wind turbine battery charge regulator, and this is the little box. It has three phase 3 yellow wires coming in from the alternator of the wind turbine, and it's got a red and black coming out which you're meant to put to the battery, and you've got a green LED and a red LED. Now at the moment the instructions say you should connect it to the battery before you just connect it to the wind turbine. So effectively I've done that. I've put 12.8 volts into the battery terminals and powered it up. You can see that showing down here, and everything's good. We've got a green LED up. What I'm doing is putting in DC into one of the phases of the 3-phase input. It doesn't matter that it's DC because it'd be being rectified internally, so I can just I can just pretend that I'm putting the turbine on. So we've got battery setting at 12.8 volts, green LED, and I'm going to turn on and turn up the voltage applied to the effectively the wind turbine generating voltage, and you'll see the voltage comes up. And if we watch the battery, I'll gently wind up the voltage, and you see the battery voltage is just starting to tick up now. Still in the green phase, it's gone to 13.17 volts, and we're putting in about 14 and a bit volts there, so that's forward bias drops of the rectifier internally in the regulator. Now the interesting thing is you'll carry on up, and I'll try and show you the picture of the LEDs on the control box and the voltage generated at the same time. Carrying up voltage, and we get to, there we go, about 15.5, 16 volts. And what happens is the box switches on the red LED, which I think means braking. Battery drops back down to its nominal voltage, whatever it is, and we can see that my input current voltage has gone over current. We look at the current, yeah, it's taking plenty of current in, so it's braking the alternator of the wind generator, shorting it out effectively, and the battery's sitting at its nominal voltage. Now the strange thing is that's okay. We've gone to 15.5 volts, 16 volts, a little bit high for a sealed lead acid battery, but when the braking kicks in, but the braking's kicked in. But the braking stays on, and the braking stays on even if I turn off the alternator completely. The red light stays on, and turn the alternator back on. So effectively the wind's dropped, wind's come up again, and it's still shorting the alternator out, and the battery's still at 12.5. So the battery is not receiving any charge voltage. Now the battery has to discharge effectively. I'm going to turn the wind right off, and the battery has to discharge down to, and we'll see this, I'm going to turn the voltage of the battery down till almost 6 volts before that red light goes off. The battery's getting flatter, 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 going down, 9.5 volts, 8.5 volts, 7.7 volts, 7.6 volts, 6.6, 6.5, 6.3, there we go, 5.9 volts. The brake went off. So we've got effectively a flat battery at 5.9 volts, not very good for a sealed lead acid battery, I wouldn't have said. We're going to turn on the alternator again, the wind generator, and we'll pick up the voltage. There we go, we're seeing the voltage coming up, and the battery is gradually rising in voltage as I turn up the alternator. Let's get up to 12, 13.6. So all in all, okay I think, but you're wasting power. You're having to let the battery go completely flat down to 6 volts before the shutdown of the braking system comes off, and you have to, then it'll charge it back up again. So your battery will cycle from 6 volts to 16 volts, something like that, and you're wasting power from the wind turbine that could still be turning even when the battery is like at 7-8 volts. It's not charging up.